Good afternoon. It's been a long day, so do you have any energy left? Come on, that's not the energy. You didn't start with the beers, right? No, it's not that time. Okay, so you have some energy left? Okay, that's better. All right, so my name is Julien. I'm a tech evangelist with AWS. Sometimes I happen to work in the Paris office, but most of the time I'm traveling, and it's great. It's my first time to Ukraine, and I'm very impressed. So, except for the weather today, but it's okay because we're going to talk about clouds anyway, so I don't mind it. Okay, so very happy to be here. I hope this is going to be useful with you. If you have questions after the session, I'll be around, so feel free to come up and ask all your questions, okay? I love to answer questions. So today, we're going to talk about AWS backends, and this seems to be a Java conference, right? I got that part right. Well, then we're going to use that. We're going to look at using those backends with Java, and of course we're going to run some code, and we're going to do some demos. And maybe they will not work, and that's okay, all right? So who am I? Well, I've been a software engineer for way too long. I ended up being a CTO and VP engineering for a number of startups in Paris. And then, I decided it was time to go and see more of the world. And so for the last 18 months or so, I've been working with AWS and traveling all over Europe, especially this month, which is crazy, right? So what to expect today? So I'm going to talk for a few minutes about writing Java apps on AWS. Well, let's ask, who is using AWS today? Okay, so they didn't lie to me. They told me, remove all the beginner stuff. They don't care. All right. Okay, but still. A few of you are not necessarily comfortable with that. So very quickly, and then we'll start with databases, and we'll talk about RDS and DynamoDB, and then we'll move on to analytics with Hive, Athena, and Redshift, and some of the newer stuff that we have released. And hopefully we'll have a conclusion for you guys. All of the code I'm going to use today is on GitHub, right? So feel free to get it and make fun of me because it's really shitty Java code. Hopefully it's not too bad, right? And if you find a bug, you can send me a pull request. I love those. So let's start with the Java apps. So, well, most of you know about AWS, right? So we have 4 deployment options when it comes to deploying code on AWS. The first one and the oldest one is deploying with virtual machines on Amazon EC2. Right, so just fire up a server and SSH to it, and it's a server. So you can do whatever you want with it. The second one is to use Docker containers. We have a service called Amazon ECS, which allows you to manage Docker clusters and schedule containers on those clusters. Anyone using ECS? Okay, all right, pretty cool, thanks. Lambda, which is the so-called serverless architecture, where you really don't care about architecture anymore, about infrastructure anymore. You just deploy code functions and you trigger them using APIs or any kind of infrastructure event in your AWS account. And you can do Java 8, of course, and I don't know if you're familiar with those, but there are quite a few open source frameworks that make it really easy to write and deploy and manage Lambda functions. Anyone using one of those, serverless or Gordon? Or, yeah, a few people, okay. I like them very much. And the last one is our platform as a service option, which is called Elastic Beanstalk. We have Beanstalk users as well. All right, yes, thank you. It's a really good one for developers. It's probably the simplest way to deploy code on AWS. And you can do very old Java or pretty new Java on some different application servers, right? So obviously we have a Java SDK for this, which allows you to invoke all the Java APIs. It goes as back as 1.6. So you should be able to use it with all your Java versions. When it comes to tools, So we do develop a plugin, a management plugin for Eclipse, which I'm going to show you today. It allows you to have, quick start for your project and run your Lambda functions and manage a lot of AWS resources directly from Eclipse. But then they told me, come on, none of these guys are using Eclipse. Come on, so don't make me feel so stupid. Who's using Eclipse? All right, you're my brothers. All right, yeah, you're my brothers. Thank you. And everyone else is using ID, IntelliJ ID, right? Oh, shit. All right. you make me feel really old. Thank you very much. But hey, at least I've got the excuse that this is only available for Eclipse, right? So they asked me, OK, please look at ID stuff, right? So I did. And we have a couple of third-party plugins which seem to be up to date. I quickly tried them, and they were fine. And there's an AWS Manager plugin, which is similar to what we're actually maintaining for Eclipse. But it's very old. It doesn't work with the latest IntelliJ version. And, looks like the maintainer fell off a cliff or something. So, well, if anybody manages to get those sources and fix them, that's better. The last thing I want to say about writing apps is how do you manage credentials? Okay, so I'm stating the obvious, but I'm sure some of you still do this because it's simpler. So please never hard code credentials in your application. The API key and the secret key, you know what I'm talking about, right? The things that end up on GitHub, right? You don't want that. You wouldn't want to have that on GitHub. Well, wait a second. Do not put them on an EC2 instance either, because you will end up putting them in that credentials config file on the instance, and this one will eventually end up on GitHub as well. And you have the problem of distributing credentials to auto-scale EC2 instances, etc. And you're going to invent something that looks really clever, but that's going to open major security holes. So please do not do that. And for the record, if your keys end up on GitHub, we're monitoring for that. And support is going to contact you with a friendly email saying, hey, you may have noticed that your AWS account has been suspended. It's because we found your secret keys on GitHub, right? So please don't do that again, and authenticate, and we'll be happy to resume your account, right? So, and that's okay, because at least if the account is suspended, there's no risk. But please be really careful with this. It will definitely end in tears. So if you need to distribute AWS credentials like the API key and the secret key, you need to use IAM roles. Okay, if you're not familiar with roles, please look them up. And if you need to distribute backend credentials like a MySQL login and password, we have a new service called the EC2 Systems Manager that has a module called the Parameter Store. Anyone uses that one? Ha! Got you. Oh, come on. Really? All right, you rock. Thank you. So this is the best way to do it. It's a very simple way of storing credentials. They are encrypted with KMS, and you can retrieve them in one API call. And so you never have to have any kind of secret stuff in your code. I'm using that as well in my code, so I'll show you. All right? OK, so that's it for now. So here's our reference architecture for backends. So data comes in many shapes and sizes and throughputs and granularity and everything. So we need to have different backends to do different stuff. So we have a first line, which is really about storing data, right? It's like Elasticache and Cloud Search and DynamoDB and RDS and ICE3, just to adapt to different shapes. And then we have a second line with the analytics services like Lambda, MapReduce, Redshift, etc. So today I'm going to talk about those two data stores, the relational database, RDS, and the NoSQL database, DynamoDB. And I'm going to talk about Hive, Redshift, and Athena for analytics, okay? But the other ones are pretty interesting too. It's just that, there's only so much you can fit in 45 minutes. Okay, let's get started with databases. So the first one, and I'm pretty sure everybody has played with this before, is called RDS. So who's using RDS? Yeah, a lot of people, right? Because pretty much every single application needs a relational database. Okay, it's pretty obvious. So the cool thing about RDS is that it's a managed service. So we actually provide you in just a few clicks or one API call. We provide you with a database instance or a database cluster even, pre-installed with your favorite engine, and you can scale it up and down. You can scale out, create replicas, etc. And it's really easy to do. You don't have to be a DBA to do it. Developers can do it. It's very straightforward. And of course, since you can scale up and down, you can adapt to traffic. You can reduce your costs. So it's really databases made simpler. We support 6 engines. So 3 open source engines: MySQL, MariaDB, and Postgres. And this is the slide that is always out of date because literally every week we keep adding a version number to those. So as of today, I think this is up to date, right? Next week, probably not. If you're a commercial user, you can use Oracle and SQL Server. And there's this last thing called Aurora. Is anyone using Aurora already? Okay, right, a few people. So Aurora is a high-performance re-implementation of MySQL and Postgres. So basically, the AWS team took first MySQL, then Postgres, and they made them, they increased performance by 5 to 10 times, right? And they made high availability better. They scaled storage much higher. You can scale up to 64 terabytes of storage. 64 terabytes for a relational database, that should be enough for literally everyone, okay? So I'm going to use Aurora today. Like you just said, everyone uses Aurora, so I could take thousands of examples. I'm just going to take one, Airbnb. Airbnb has been using RDS from day one. They've been running on AWS from day one. And they've always managed their databases with RDS. So, I guess it scaled pretty well for them. And if you own a Lamborghini, I'm not going to ask that question. Lamborghini is using RDS as well. I'm not sure why, but probably smaller scale than Airbnb, right? Okay, so let's take a look at Aurora. And so, like I said, Aurora is based on MySQL and Postgres, but today I'm going to use the MySQL version. So how do you connect to all those databases anyway? Well, the good news is you've seen this a million times before, right? This is vanilla JDBC code, nothing specific, right, to AWS or anything. So this is how I'm going to connect to all those backends, okay? You've seen this a million times. The only difference is, in some cases, I'm using AWS credentials to do it, so I don't have any login and password. And for some other services, I do need a login and password, like MySQL, for example. Okay, and then I need to provide it. And how will I grab those? Well, like I told you a minute ago, I'm using the System Manager parameter store, and so I entered my credential in there. And I can just grab them, I just build a request, and I ask for the parameter to be decrypted, and I grab it, okay? And this is how I will get my login and password for MySQL and for Redshift, okay? So this is the proper, secure way to do it. Okay, so let's look at Aurora. So Aurora, you can use the normal MySQL driver to connect to Aurora. So I created a cluster before the talk. That's the endpoint. Okay, so I'm getting my credentials from the parameter store, like I showed you. I'm connecting to that Aurora database, and then I'm calling an API, a Java API, to describe the database, right? Describe the cluster, and then I'm running a query. So it doesn't really matter what that is, but it's a large data set. I've got a table with 1 billion lines of fake sales. They're not Amazon sales. I didn't steal that data. That would be my last talk ever. That would be my last everything ever, I think. You would never find my body again. So anyway, there are fake sales, and I'm looking for users called Jones who live in Florida. And the way I'm querying for this, again, you've seen this a million times before. I'm using JDBC prepared statements. And this, again, this is vanilla Java code, right? Nothing specific to AWS. So, and of course, let's run it. Okay. And I do need my console. Okay, so let's try Aurora. Okay, so I got my credentials from the parameter store. I described my cluster, and I found 226 people called Jones in Florida, right? And what I just did here, I did a simple select on one table with 1 billion lines, right? And it took no partitions, no nothing. It took about a second, because obviously I've got the right indexes, okay? So my message here is don't rush to NoSQL. People think NoSQL is always faster. Well, not necessarily. If you know what the queries are going to be, and if you can optimize for those queries with the right indexes, then you can make relational databases faster than anything else. Okay. Obviously, if I run a count, right? If I run select count last name on this, it's running for 10 minutes, okay? Because it's a full scan, and a full scan on 1 billion lines is going to hurt. But if you can hit the indexes right, you get really good performance, especially with Aurora. Okay? And now you can do this with Postgres as well. So let's move on to DynamoDB. So DynamoDB is a NoSQL database. It was built by Amazon in 2004, and then it became an AWS service in 2007. So it's been around for a while. And it's a fully managed service. So it's even more managed than RDS. You don't even have to create clusters. You don't have to create instances. The only thing that you do is create a table, call an API, create a table, and get your items, and that's it. Okay, so it's a very high level service. Developers usually love it because the infrastructure is completely hidden and invisible and abstracted. Okay, and of course you can scale it up and down, and it's pretty cool. So let's look at for this customer, for example, Expedia. Everybody knows Expedia, right? And they use DynamoDB to run their analytics. Okay, so all the events that come from all the websites and all the mobile apps, they go into DynamoDB for real-time processing. And so it's about 200 million messages a day, right? So it's a lot of traffic, it's a lot of data, and it works pretty well for them, right? And since the service is managed, you can be up and running in a couple of days, even if you just have to learn Dynamo from scratch. There's no fuss. Create tables, put and get, and you're on your way. And that's why I'm saying developers love this system. So let's take a look at it. So one thing I should mention as well is here I'm going to use the real DynamoDB, the one in the cloud, but there is a local version of DynamoDB that you can download to work locally on your machine. So this is really great for me when I'm spending my life on planes and trains and I don't have a network connection. I can still work. But for you guys, it's really good for local testing, local development. You don't have to go to the cloud and with the latency and anything and the cost. You can work locally, so you can install that database locally. And work with it, okay? But here I'm going to connect to the real thing. So I'm connecting to DynamoDB in the US, okay? I'm creating a table. So let's look at that. So it looks a little ugly because I made it a bit complicated, but so it's NoSQL, so I'm not using SQL this time, obviously. So I'm adding attributes to that table, so it's a movie database. So movies have a title, a rating, and a release date. I can create I can create a secondary index, right? I want to have an index on ratings. Why not? And then I'm creating the table. So the sharding key will be the title. Okay, the other attributes are rating and release date. I'm adding that index. And this is an indication on how much data I'm going to read and write to that table. Okay, and that's an important factor because it drives the cost. Okay, so the more you provision, the more you will pay. So make sure you only provision what you need. Okay, then I need to wait for a few seconds for that table to be created. And that's it. Okay. And so I'm going to add some movies to that table. Right? So put item. Nothing complicated. And yeah, I'm sorry, but I'm pretty obsessed with Star Wars. I guess I'm not the only one. I'm going to print one of the movies. I'm going to add a character to the Return of the Jedi. Make sure it's been added correctly. I'm going to print all movies with a 1-star rating. I'm going to print all movies with a 5-star rating between 75 and 82. Then I'm going to print all the movies from the series Star Wars, and I'm going to print all the movies with Yoda. And I'm going to delete all the bad movies, etc. So these are all examples of the API, right? So these are examples of put item, get item, update item, query with an index, query with the hash key, and scan the full table if you don't have indexes or a hash key. Okay, so you can look at that code and see what it looks like. So maybe let's just look at a simple one. Create movie, so that one. Yeah, for just this one is very simple. So, okay, if you need to get an item from the table, that's it, right? You call get item, and that's the DynamoDB API here. And you just provide the hash key, and you get your item back, okay? If I want to do, find all the movies with a given character, okay, well, I don't have an index for that, so I need to scan the table this time. That's not a very fast operation, but sometimes you have no choice. And so obviously I'm going to say, well, I need to build a scan request, say if the characters contain the character passed as the parameter here, well, you know, just build the item collection for those items, and then I'm printing them, okay? So again, you can do put and get and update and delete, and then you can query on indexes or the hash key, and if everything else fails, you have to scan, okay? And that's pretty slow. Okay, so you can look at that one, and let's do this. So here's the AWS plugin for Eclipse. So I'm connected to the US. So let's start by creating the table. So this takes maybe 10 seconds, okay? Because it needs to provision a little bit of infrastructure to run the table, and then we're going to roll out all of those API calls. And I should see my table showing up right here. Whoops. Come on. Okay, so here's my table. My items are here. And well, I did pretty much what I had to do here. So created the table, described it. I did my movies. Got some information for Return of the Jedi. And Jabba is not in there. Added Jabba. And now it's in there. Found all the 1-star movies. I think we'll agree on that one, yeah? Anyone thinks Phantom Menace deserves more than the 1 star? No. Don't raise your hand, come on, don't do that. Okay, finding the 5-star movies for this time range. Finding all the Star Wars movies. Finding the movies with Yoda. Deleting bad movies, and they're gone, okay? So it is NoSQL, so it is not SQL. So you have to understand how tables work. You have to understand the API. You have to understand what are the queries that you can do, right? You can only query on indexes and hash keys and range keys, but not on the rest. So if you need to do something on the other columns, then you need to scan. Okay. So here's a sum up of some of the backends, and I added some extra information. So don't worry, we're not going to read all of this. I really included it for reference. But you can see the major difference between Dynamo and RDS is not so much about scale and performance. It's really about, do you have structured data, or do you have a schema, or don't you have a schema, right? This is really the main driver, okay? Okay, let's move on to analytics, because it's very nice to have all that data in there, but now you want to crunch it, okay? And sure, you could crunch it with Aurora. You know, you could write 2 pages long SQL statements and do that on Aurora, but Aurora is, is not a data warehouse. It's not going to scale for SQL requests, SQL queries that last for 15 minutes. So the first one we're going to look at is Hive on EMR. So EMR is the managed service for the Hadoop ecosystem. Anyone uses EMR? A few people, all right. Well, after my talk, you will move on to something else. So EMR is Hadoop and Spark and Hive and Presto and Flink and HBase and everything. So it's like RDS, right? With one API call or a few clicks, you create your cluster and everything's ready. Okay, you don't have to install Hadoop, you don't have to worry about that. And you can resize it, and you can terminate it, and it's very flexible. So you're never afraid to start a cluster, kill it, etc., okay, to save money. So we have tons of customers who use this, but this is probably one of the largest. It's a regulator, it's a market regulator in the US called FINRA. So they have to look at every single stock trade and option trade done during the day. And so they pile them up, literally, billions and billions and billions of transactions every day. And then, once the market is closed, they run all those transactions into their machine learning systems to figure out if something is suspicious, right? And sometimes it is. And to do that, they use up to 10,000 Hadoop nodes on EMR. And they don't need them during the day, right? Because during the day, they can't do much. They have to wait for the market to be closed. So they really only need that infrastructure at night, right? And so it would be silly to buy 10,000 nodes that are idle during the day and just working at night, right? It's a waste of money. So with the elasticity that EMR gives them, they can scale super high when they need it and then kill everything when they don't have to work with it. Okay, and that's really how you should work with EMR, right? Your cluster should be short-lived, start them, load the data, crunch it, get the results, kill the cluster, right? Save money. So let's look at Hive. So connecting to Hive is, here it is. Connecting to Hive is similar to what you would know. You will use the JDBC driver, okay? The only thing is you don't want to expose your EMR cluster on the public internet, right? So it's running somewhere in a private subnet in your account. And the way you authenticate, the way you connect is to open an SSH tunnel to it, okay? So this is why here I'm not connecting with any login or password. I'm SSHing into the master node, and then I'm sending my code, my queries. Okay. So I will. Well, let me start it because I hate to say it, but it's Hive, so it's a bit slow. Yes, and I can explain it while it runs. So here I'm describing my cluster. And then I'm running that same SQL query, okay? So Hive is not strictly 100% standard SQL. but it's pretty close, right? In this case, it's fine. It's a simple query. And can I see this thing running? Yeah, it should be running. See? Aurora was 1 second. Come on. Oh, I see a tiny thing showing up here. Very nice graphs, by the way. I mean, I love the colors. But this is a bit slow. And it's a decent sized cluster, right? I mean, if you guys are familiar with instance sizings, I'm using a 10 C4 2XL instances. So it's like, 160 cores total and 300 gigs of memory total. So it's not a ridiculous cluster. Oh, it's over now. Okay. So it takes about a minute, to be honest. And I still find those 226 Joneses in Florida. But it's Hive, right? And, Hadoop tries to promise you that your job will complete, but never makes any promise on how long it would take. And, well, that's the way it is built, right? Yeah, so, okay, it worked, right? And we can see crazy network traffic because we have to load the data. And we can see the nodes working. So, I don't want to pick specifically on Hive, but, it's been around for a long time now, and there are better options. That's what I'm saying. And one of those is Athena. So Athena is a new service that we announced a few months ago, and it allows you to run read-only queries, so selects pretty much, on data that is stored in S3. So you could have petabytes of data in S3 in multiple formats, and you would query that data directly. You don't have to load it anywhere. So it's a huge time saver. No data loading, no indexing, nothing. Okay. And obviously no infrastructure to manage or scale. This is all done automatically by the service itself. So it's based on Presto, which is an open source project, which was available on EMR, but we made it even simpler. And the only thing you have to do is to create your table, right? So you create a table that maps to the layout of the data in S3, so that takes 1 second. And then you can run standard SQL on that data, okay? And that data could be in many formats. It could be unstructured, it could be semi-structured, it could be structured, and especially if you use columnar formats like Parquet or Orc, which are really good for performance, then, and that's what I'm using, you're going to get very, very good query times. Okay, so it's highly recommended that you take the time to transform your data from, let's say, CSV or TSV to the columnar formats. And you can do that pretty easily with Hive, for example. And you can do also compression and partitioning, which will increase even more the performance. So we're going to look at this in a minute. Well, the service is quite new, but we still have a lot of people. We already have a lot of people using it, like DataXoo. It's an ad tech company in the US. And as you probably know, ad tech means lots of data, right? Because they're doing, real-time bidding. They're getting billions and billions and billions of data requests coming into the platform. They log everything. They crunch it with machine learning, but they also store it in S3, and they do some BI and some analysis using Athena. Okay, it's 180 terabytes a day, so it's pretty big, right? So let's look at Athena. Sorry. So again, you will connect with JDBC using Athena. And here, just to make it a little different, I'm using local credentials. So I'm using credentials running on my laptop to authenticate to Athena. There are many ways to do it. That's just one option. So I'm building a client, and I'm calling one of the Athena APIs to get the last 3 queries, and I print them. And then I just connect, and again, no login and password this time. I just use AWS credentials, and I run the same statement. The only thing is, why the extra quotes? Well, the problem is that for now, prepared statements are not supported. And that's not really Athena's fault, it's because they're not supported in Presto, on which Athena is based. So that's the actual issue on GitHub. They are working on it, but for now, we cannot do prepared statements. So I have to use a normal statement, and pretty soon I'm sure we'll have it. And listing past queries, is just one API call away. So let's try it. Okay, so here are my last 3 queries. So I can see the execution time, I can see how much data I scanned, etc. And then I'm running my select on Athena. And again, 226 rows. And it takes about 6 or 7 seconds. Yeah, 7 seconds, right. Okay, 7 seconds to go through 1 billion lines of data stored in S3. Loading time 0, management time 0, scaling time 0. I have to say I am madly in love with this service. So if you use Hive today, and if you use it just for read-only stuff, right? You load data in HDFS, and you query it, you aggregate it, whatever, and you get results, right? Please look at Athena. You're going to save hours, right? Hours. So it's a very, very good service. And even if you do only, exploration, you need to go through the logs to do some debugging, or, in any kind of ad hoc analysis, Athena is perfect. You will be up and running in literally minutes. Literally minutes. No infrastructure to manage at all. And the last one I want to talk about today is called Redshift. Anyone using Redshift? Oh yeah, cool. Okay, so Redshift is our data warehouse. It's based on SQL. So it was evolved from Postgres. So it's Postgres SQL basically. So if you know SQL, you know how to use Redshift. You don't need to learn some kind of bizarre language. It's completely managed, like RDS. Just click or call an API, and after a few minutes you get your cluster. It's massively parallel. You can scale it up to over 100 nodes working in parallel on the same query. So it's going to be blazingly fast. And you can scale it to multi-petabyte scale if you have to. Okay, so it's very simple to use, but very, very scalable. And it's pretty inexpensive when it comes to data warehouses. You can get to about $1,000 per terabyte per month, which is a very, very competitive price. If you have, let's say, competing data warehouse, just look at the price and you'll see this is very good. And there's an extension now, which is again very recent. It came out about 2 months ago, which is called Redshift Spectrum, that brings Athena-like capabilities to Redshift. So now Redshift can query data that is stored locally on the nodes, but it can also go and get and join query that is hosted in S3, right? So you get the best of both worlds, and this is how it looks like. So you send a query to the leader node, the master node. It's going to build the execution plan. It's going to split the query across the compute nodes. So each compute node is going to run that part of the query on the data that is local. And then they're going to send back the results to the leader node, and you get the result. Okay? So you can load data from S3 and Dynamo, etc. And if the data is stored in S3, you can go through Spectrum, and you have a fleet of managed nodes, right? Very, very scalable, that is going to work on that data. So you get both the fast, local, super optimized queries on your local nodes, right, for reporting or analytics, etc. And you also have the capability to go and query petabytes of data that is hosted in S3. You do not have to host it on the cluster itself, right? And again, you can save tons of money by doing that. So what customers say about Redshift, well, to keep it simple, they say it's super fast. A lot of people left Hive to move to Redshift, and they reported 20 to 50 times faster, right? And now with Spectrum, it's even better. Okay. So again, if you have both needs, if you need data warehousing, okay, for BI and reporting, and if you need the capability to query tons of data, but you want to do this, every once in a while, and you want to do it at a very low price, then Redshift and Spectrum is a great combination. Okay, if you don't need BI, if you don't need a data warehouse, then you can use Athena, right, which will give you, like I said, the capability to query that data. Okay, but you have lots of options actually. So let's look at Redshift now. Last one. So again, Redshift is JDBC. Okay. You need a login and a password. So again, I'm grabbing those from the parameter store. I'm connecting to my cluster. I'm describing the cluster. And I'm looking for the Joneses in Florida. Okay, so it's almost the exact same code as Aurora, right? Okay, so let's do that. Okay, credentials, description of the cluster, query, boom. Right, and that data here is in S3, right? So it's the exact same data set that I used for Athena. So it took Athena 7 seconds, right? How much did it take for Athena Spectrum, Redshift Spectrum? We can do it again. 1 second, 1.5. So those billion lines, they're not on the Redshift cluster. They're in S3. Okay, so Spectrum is the Formula One of AWS backends. I'm madly in love with Spectrum too. Can you love two backends at the same time? I don't know. I have to choose. So let's sum things up. Again, very different things. Hive was great for a while. Now I think Athena is literally a better option for most use cases. Redshift was already very good for BI and data warehousing. Now with Spectrum, it's even better. Okay. I'll let you guys take a picture. I will post the slides on Twitter tonight, so you'll get everything. Okay, but then again, if you love Spark, then by all means, run Spark on EMR. Who am I to tell you not to do this? So here's the reference architecture again. So as you can see, you can use both data stores that fit the data that comes in and data analytics services to crunch them, to crunch that data, and potentially crunch data coming from S3 and different places as well. So, it's very flexible. Last thing I want to say is, how about migrating your databases to AWS? So you could be migrating from on-premise infrastructure. You could be migrating from inside AWS, right? Let's say you have RDS Oracle and you want to go to Aurora, for example. Can we help you do that? Yes, so we have 2 tools to do this. The first one is called the Schema Conversion Tool. It's an app that you download on your machine. You connect to your database. You say, okay, I want to migrate this to there. Here are the tables. Here are the objects I'm interested in. It's going to look at it, and it's going to try to convert the schema and the objects automatically, right? And anything that it cannot do, it's going to highlight it and give you some pointers and, show you exactly what manual work is needed to transform the schema from one engine to the other. And then when you're ready to do the migration, you can use the database migration service, which is exactly what the name means. You define a source database, a destination database, you select the tables, you click, and it starts replicating and handling the schema changes from one engine and then to the other. Okay, so it's very popular. It's very easy to use. You have tens of thousands of databases that have been migrated like that, and you can use it for relational databases and data warehouses, like the ones that I mentioned on the previous slide. Okay, so as a conclusion, you have a very large choice of backends. You can start from stuff that you know, right? MySQL, Postgres, and save yourself the trouble of managing the infrastructure by relying on RDS. You can use NoSQL and DynamoDB to have super scalable databases as well. You can have big data and analytics that fit pretty much all the use cases. So these are really all the tools you would need to build your backend stack, but we try to remove as much infrastructure drama as we can, right? Because we know you want to focus on building your app, and you don't want to focus on the plumbing, right? You want to build your product. Okay, and for most of these services, we bring out of the box, high availability, scalability, security, compliance. You don't have to worry about any of those. Okay, when you use Athena, when you use Redshift and the others, all of this is built in. So you can again focus on designing your tables, designing your product, and not on the rest. It's our job to do it. Okay. So again, focus on creativity, build great stuff, build great apps, leave the plumbing to us, right? This is what we do, and we're happy to do it for you. Thank you very much. Thank you very much to the organizers for having me today. It's again a very nice event. I am quite impressed, and I'm definitely enjoying my stay in Ukraine. And something tells me I will be back this year, but it's too early to tell, right? And I don't want to talk about competing events, but we might see each other again. So thanks again. Enjoy the rest of the day, and if you have questions, I'll be happy to answer them. Thanks.